Well, here we are again. We are back out on the streets, and we've had a little bit of time in a hotel and bed and breakfast, and we've settled down to the coming of spring. Now, we have just been through some design structures of new, what's the word? Well, of new quantum thinking, shall we say? All right. Now we're going to talk about space and displacements of space and volumes of gravity and the weights of gravity and the overall effect of gravity in space. Now, when you think of a volume of gravity, which is very similar to the volume of gravity of the device of which I have put a plan of action together to test. Volumes of gravity, regardless of the volume, will float in space. Now, displacement of space over the volume of gravity means that in a radial diameter of a volume of gravity, there is a mild displacement of space. Now, because the volume of the gravity itself floats in space, anything that enters the region of the center of the volume of gravity mass will fall in this area. It will come in through floating in space, and it will enter the volume of gravity. But the volume of gravity is floating in space. It floats in space. So if you enter the volume of the gravity itself, the object itself, depending on the volume of its mass, will also float in space, but inside the volume of gravity mass. Now, when you're inside the volume of gravity mass, then there will fall upon the ship an area of gravity. It will use the volume of the mass of the ship to calculate the gravity that will be needed for the internal ship space. So all of a sudden, there will be gravity in the ship, in the space of the ship, inside. The volume of gravity outside is floating in space. Now, as you enter the volume of gravity, there may be a mild effect of gravity fields of the volume of the weight versus the volume of the gravity of the mass. If you can move in and hover under, let's say, jets or engines, you will be able to stabilize your position in the volume of the mass of the gravity and float, and also incur gravity in the ship. Now that's if there is a volume of gravity, right? So you move in and you float, but because of your volume of mass in the ship versus the volume of the gravity that is floating in space, you will still float, right? Now, if there are no engines and there aren't anything that will help you keep up in the volume of gravity, you may drop. Depending on the size of the gravity, you may drop all the way through and fall into floating space or an area of space where you float. If you drop something at the top of the volume of gravity and it drops down and equalizes itself in the volume of gravity and realizes that the volume is floating in space, then the volume of the mass will determine on whether it passes all the way through or whether it floats in the center. Now, if you can imagine a bubble that you can control in a bottle by squeezing it to the point where you can pressurize it to the point where it will equalize itself and float, right? Then we have what we call a level. So if you have a program that will calculate the volume of your mass and calculate the volume of the mass of gravity, you can level your ship in a volume of gravity in space that is floating in space. Now that is the volume of mass. Now there are lots of things that you can do with volumes of mass, and lots of things that you can calculate with the volume of mass. Let's say your gravity field is generated and created inside the ship, which incorporates the whole weight of the ship, and you become the volume of gravity as a ship. It means that your ship, as a volume of gravity, is seen as a particle in space that will float. And the particle of a ship particle that floats with its volume of gravity, if you extend the volume of gravity's effect outside the region of the ship, then it means that you have an area of a volume of gravity which is outside the area of the ship. And it also means mild gravity, let's say moon gravity on the outside of a ship, would be very useful if it was the volume of the gravity effect, where you would have the moon gravity outside the ship. Now, in the center of the ship, you would have a heavier gravity, and on the outside of the ship, you would have, let's say, moon volume gravity. You could get yourself out of the ship and have mild moon gravity. You'd be able to move across the surface of the ship, bouncing around all over the place. You'd have stabilizing factors where you could hold yourself under light gravity on the outside of the ship. And when you came back into the ship, you would enter a slightly heavier gravity and be able to keep yourself stable on your platforms and your walkways. Now let's say you go outside the influence of the gravity of the ship, and you then become a floating object around the ship rather than being affected by the mild gravity. You would be able to calculate yourself an orbit. You would be able to calculate yourself and program yourself an orbital pass and an orbital spin. And you should be able to definitely have laser lock-on to the order of your ship and be able to calculate your laser lock-on and then traverse the whole area of your vessel having a look, just to see. So let's say there is a drone that you release from your ship and it gets itself a laser lock-on and it starts an orbital orbit around your ship. These things are possible with the right technology and with even the technology that we've got already existing. All these things are possible today. Nothing of it is new, but it's all down to application and exactly what we can do with it. So let's say that we do have a volume of gravity, and I know that we do. And let's say that we use this volume of gravity, which I know that we have. And if we manage the order of the manipulation of it, which I know we can, we are then in a new era of space, with gravity in ships and mild gravity on the outside of ships, and a volume of a magnetic field around the ship. Sounds science fiction, but it isn't science fiction. It's physical science. So let's get building, because I'm in the area of production and making.